Hi, this is Daniel Nielsen from the Intel FPGA Division University Outreach Team. Not only will this video introduce you to our huge amount of online FPGA training resources, but it will detail access to a plethora of free Intel resources that can be used to bolster your learning and curriculum. We feel that FPGAs make for fantastic electronics learning vehicles as they can handle simple to very complex projects and are quite forgiving with their ability to be reprogrammed. The Intel FPGA academic ecosystem serves the purpose of helping professors and students learn all about FPGAs, generate new top-tier talent for Intel and our partners to hire, and engage in leading-edge FPGA research. In March 2020, the world as we know it, as well as how we teach and learn, was changed for the foreseeable future. Electronic labs are expensive to set up and require a variety of equipment that is often shared by students. Generally, there isn't enough of each type of equipment to go around for each student. Virtualized training in 2020 is the norm. Despite our fast-moving and tech-rich world, professors and their students had to scramble to adapt to online learning practically overnight. Altera Corporation launched their FPGA business in the early 1980s and was acquired by Intel in 2015. In 2006, Altera launched the FPGA University program, and we created FPGA-centric coursework and development boards geared towards student learning. Launched by renowned FPGA professor and author Stephen Brown of the University of Toronto, we offer coursework, labs, and tutorials across a variety of FPGA disciplines. The FPGA University program offers both undergraduate and graduate level training material with an emphasis on online teaching resources. Let's take a look at the undergraduate coursework offerings. Our undergraduate FPGA coursework spans 4 different courses typically offered in electrical and computer engineering curriculum: digital logic, digital systems, computer organization, and embedded systems. Worldwide electrical and computer engineering programs tend to offer some or all of these courses as part of their curriculum. Intel's Quartus Prime Lite FPGA development software is completely free and satisfies most undergraduate FPGA study programs. Not only can you design FPGAs using schematics, hardware description languages, high-level languages, and configurable IP blocks, but it also includes the Mentor Model Sim Logic Simulator and Eclipse IDE for our popular Neo soft processor. In FPGA terminology, a soft processor refers to a processor built from the FPGA fabric lookup tables. Compare the Neos to a hard processor ARM-based SoC-style FPGA that combines the power of an ARM application processor sitting next to an FPGA programmable fabric. Our coursework is delivered in the form of tutorials and labs. Tutorials train the student how to use a specific Quartus tool or development kit feature, while labs describe an electronics concept that is given as a lab exercise to reinforce learning and understanding. These materials are used in thousands of labs across the world. Tutorials include design description of FPGAs using schematics, Verilog and VHDL hardware description languages, as well as parameterized IP blocks. Use the tutorials to learn the tools and use the labs to build projects to reinforce various electronic engineering concepts. In addition to design entry techniques, we also include detailed tutorials on Quartus features for timing, simulation, and debug. These are valuable skills for students to gain proficiency in FPGA design as they proceed through their electronics undergraduate and graduate level curriculum. Keep in mind the training material and Quartus tools are entirely free, while the development kits are donated by Intel or can be purchased for an affordable price. Our system design tutorials include extensive instruction on IP block integration, use of the integrated ARM processor and associated subsystems, software libraries usage, and development flows for debug. The tutorials are useful throughout the entire span of undergraduate and graduate level electronic and computer engineering training. The lab offerings offer students hands-on work using concepts and topics discussed in lectures and textbooks. These 12 labs increase in complexity and are typical of a 15-week semester training in digital logic. The labs start with combinational logic, progress into sequential logic, and then delve into small applications. Solutions are available to the verified professor community by requesting through the members site. There is no need to author your own lab manuals, as thousands of worldwide labs are successfully using this material. The computer organization lab material is centered around the understanding of microprocessors, instruction sets, memory organization, assembly language, and C language, and include fun labs using graphics and animation. Lab material is offered for both the Neos 2 soft processor and ARM A9 processor. The Integrated Development Environment, or IDE, is made for our Academia Monitor program, which simplifies understanding the inner workings of microprocessor registers, instructions, branching, and data flow. The Embedded Systems Lab material teaches the student about development of embedded applications using an SoC FPGA running the Linux operating system. These labs combine the use of processor and external FPGA-controlled devices and serve as an excellent foundation for students looking to expand their knowledge of where the hardware and software worlds intersect. Students will learn about Linux and writing kernels that run on the processor and can control the customized FPGA hardware. Terasic is the Intel FPGA Division Trusted Academic Development Board partner. Terasic is based in Taiwan, China, and the US and offers dozens of FPGA development kits spanning first-time electronics programming to embedded systems, camera peripherals, as well as robotics. All boards are pre-programmed with a golden system design that demonstrates how to interact with each I/O interface on the development kit that is connected to the FPGA. Some development boards are powered solely by the USB power supply, while others require an included power adapter. Prices for academia are subsidized by Intel to give universities access to world-class FPGA development kits at affordable prices. You will only find FPGA development kits with these capabilities at these prices from Terasic. The Terasic DE10 Lite development kit contains a number of I/O interfaces, including push buttons, slider switches, LEDs, and 7-segment displays. The DE10 Lite also includes a VGA interface useful for training on the use of video graphics. I/O expansion comes in the form of the popular Arduino header form factor, where a variety of low-cost expansion daughter cards, such as Bluetooth, Wi-Fi, displays, and cameras can be connected to the FPGA host board. The DE10 Lite is Terasic's most popular board and is used by thousands of students across the world. The price point of $55 makes procurement by every student quite feasible. An abundance of training tutorials and labs is written for the popular DE10 Lite board. The DE1 SoC development kit utilizes Intel's Cyclone 5 FPGA, which includes dual ARM A9 processors with a variety of connectivity interfaces, including UART, USB, Ethernet, GPIO expansion, audio, video, and an SD card reader to boot Linux operating systems. Linux builds are available from Terasic, Intel's university program website, and through our Linux development portal rocketboards.org. The DE10 Lite and DE1 SoC are just a few of the dozens of offerings from Terasic that can help facilitate your FPGA learning curriculum. Please visit terasic.com for details. In addition to FPGA development kits, Terasic offers robotic kit boards that are ideal for senior design and capstone projects. The out-of-the-box experience for the self-standing robot includes the ability to drive the two-wheeled robot via infrared or USB control, collision avoidance, and object following. All the source code is included with the board, and student groups have added features such as voice control and pre-programmed dance moves. Other robotic kits include a spider bot and a Rubik's Cube solver, ideal for challenging undergrad and graduate students with writing Verilog or VHDL and C to develop embedded projects. The onset of COVID-19 has fostered innovation in the area of remote learning labs. Our remote learning system enables development kit access from the confines of a student's home. The student gains full use and viewing of development kit tactile interfaces such as switches, push buttons, LEDs, and 7-segment displays. Development kits can be hosted at the university or even a professor or TA's home, and students can remotely access boards and program their FPGA lab work. We also offer a simulation-based console that is great for new FPGA learners and requires no hardware or test bench. The Intel FPGA Remote Lab infrastructure has two different usage models. In Model 1, Quartus is hosted on a server with a connected development kit. The student uses a virtual desktop infrastructure or virtual desktop to connect to a Quartus server. The student can run their lab work, program their development kit, and view and interact with a remote console on their own home PC. It's like playing a video game with live FPGA hardware. In Model 2, the student runs Quartus on their home PC and doesn't need a virtual desktop interface into the university compute center. The student is given an IP address and password to the development kit hosted machine. A single Linux server can host dozens of development kits. Check out the GitHub link to download the instructions and files to set up your own virtualized hardware training environment. Intel offers a number of workshops crafted just for universities. FPGA topics are technical in nature, and we also offer advice on how to get hired in the tech industry, as well as a semiconductor industry overview to give students new skills and knowledge they might not acquire in their normal curriculum. Contact Intel at fpgauniversity@intel.com to inquire about workshops that can be offered on-site at your university or remotely through your favorite video conferencing software. Our Intel FPGA technical site has dozens of online and instructor-led courses you can take. There is a wide variety of courses for the hardware engineer and software engineer, from first-time users of FPGAs to advanced topics on optimizing your design for maximum logic packing, performance, and throughput. Courses are organized by track and level of complexity. Please feel free to view the schedule covering several months of course offerings. Course attendance is free of charge for professors, so please take advantage of the rich set of FPGA coursework brought to you by Intel. The Intel FPGA training site offers hundreds of courses on every FPGA topic imaginable. Filter through the various selections and find the course that suits your needs. Some courses are online and self-directed, while others are offered through our expert instructors in person or virtually. Intel offers virtual connectivity to run all labs. Becoming a member of the Intel FPGA University program has its advantages. You can request development kit donations, Quartus licenses, and solutions to our semester-long training curriculum. Submit a photo faculty ID as proof that you are affiliated with a university or FPGA teaching institution to receive these benefits. To request licenses and development hardware, sign up, wait for approval, and then proceed to the Request Hardware page. Hardware donations are generally fulfilled and in your hands in under 2 weeks. The Intel FPGA University program also offers a rich set of material and resources geared for the graduate level teacher and learner. Let's take a look at various heterogeneous computing offerings on our FPGA cloud services. Data center and cloud computing services are adopting new methods of workload acceleration that include FPGAs, GPUs, and an array of specialty computing devices that ensure that your workloads are operating at maximum performance and efficiency. This trend of heterogeneous computing workload acceleration is widely studied in graduate programs, and Intel offers numerous resources in course preparation and research. Heterogeneous computing spans the worlds of software and hardware engineers. Intel offers a comprehensive set of libraries, software stacks, and compilers to optimize your heterogeneous programming projects across a wide range of end applications. Supported languages span the software space, including C++, OpenCL, and data parallel C++, as well as hardware description languages such as Verilog, System Verilog, and VHDL. Graduate-level heterogeneous computing coursework often utilizes expensive state-of-the-art FPGAs that can run in the thousands of dollars per development board. Installation of the software, firmware, software stacks, and libraries can take considerable effort. The Intel FPGA University program removes the cost barrier and installation complexity by offering the Intel FPGA Dev Cloud and a program known as HARP, two FPGA cloud services focused on academic courses, developing projects, and conducting research. The Intel FPGA division offers two different cloud services for academia: HARP, the Hardware Accelerator Research Program, and the FPGA Dev Cloud. HARP is a research-focused cloud service that is primarily for multi-year research engagements. HARP usage is by invitation. If you're interested in HARP, refer to the email address shown below. The Intel FPGA Dev Cloud is for broader use in enabling heterogeneous computing labs in shorter-term FPGA-based projects. Both services support similar workload compilations, although HARP is a little more flexible in allowing the researchers to modify libraries and settings. There are 5 workflows for Intel FPGA heterogeneous computing. You can use Verilog, System Verilog, or VHDL to create an FPGA workload accelerator that communicates across the PCI Express connector to move data to and from the CPU host and FPGA platform accelerator card. You can also utilize 3 different C++-based high-level synthesis flows: the HLS language, OpenCL, and data parallel C++. HLS focuses on block-level design, while OpenCL and data parallel C++ focus on a full chip level design. The full chip approach focuses on the software engineer, with all I/O interfaces, memory management, and data movement between host and FPGA handled by the Intel provided stack. OpenVINO is a vision machine learning overlay. The FPGA is pre-programmed with a configurable neural network where weights and attributes are determined by the designer. OpenVINO allows students to explore various neural networks for efficiency and throughput. This diagram shows the 5 different flows and where the compilers are utilized in the flow. Note how the C++-based flows, HLS, OpenCL, and data parallel C++, transform high-level parallel programming code to synthesizable RTL code, which in turn is synthesized by the Quartus development tools. In each case, a combination of CPU host code and FPGA workload acceleration code work in tandem to implement a variety of complex parallel programming applications. Currently, the DevCloud and HARP support both the ARIA-10GX programmable acceleration card and Stratix 10 programmable acceleration card. The ARIA-10 pack card is based on the 20nm ARIA-10 family of FPGAs and includes 1.15 million lookup tables, 8 GB of DDR4 memory, 128 MB of flash, and a PCIe Gen 3 by 8 interface to the host. The Stratix 10 D505 programmable acceleration card is based on the 14nm Stratix 10 family of FPGAs and includes 2.8 million lookup tables, 32 GB of DDR4 error correction memory, and a PCIe Gen 3 by 16 interface to the host. The Intel FPGA Dev Cloud will be populated with new pack cards such as the Agilec 10nm pack card when available. The Intel Dev Cloud offers 3 different instances with unique logins: IoT, One API, and FPGA. The link shown will take you to our free sign-up page for the FPGA Dev Cloud service that contains the latest in Xeon servers and FPGA platform acceleration cards. Note that when you sign up for the FPGA Dev Cloud, you also gain access to all of the computation and workload compilation capability of the One API Dev Cloud. By default, login access lasts for 90 days. You will be reminded to extend your login should you need additional time to complete your learning and FPGA acceleration projects. To gain access to the Heterogeneous Acceleration Research Platform, or HARP, for PhD-based research, send an email to the link shown on this slide. Please communicate the details of your research project. The wiki link provides further details on the HARP cloud service. The Intel FPGA University offers resources that span first-time electronics learning to the PhD FPGA researcher. The rich set of training resources will help your students excel in the world of FPGA education and professions. We know that teaching students in the remote learning environment we live in can be a challenge. The Intel FPGA University offers you numerous resources to help you and your students succeed as electronics professionals. Should you need help in your FPGA education programs, feel free to contact us via phone or email. Thank you so much for watching.